Hello friends, we are back. So we're going to do another problem here talking about factoring polynomials to find zeros. So in this case, the problem says given that -5 is a zero of this polynomial function, f of x equals x cubed plus 5x squared minus 2x minus 10, we need to determine the other zeros. This problem requires a lot of synthesis and pulling other pieces of what we've learned together. So one thing that we learned in our previous section is that you can use synthetic division to factor. And when I want to find the zeros of something, I want to factor it. So here I'm given x equals -5 is a zero. X equals -5 is a zero. So that means x plus 5 is a factor of f of x. Okay? We are dealing with a cubic, x cubed, a cubic polynomial, and a cubic polynomial has 3 zeros. So we know 1 zero, we need to find the other 2. So what I'm going to do is I'm going to use synthetic division or synthetic substitution to factor this. So I plug my 0 up into the top. Remember, when we do synthetic division, we don't use the factor, we use the 0 that comes from the factor. So I'm going to use x equals -5. And then I'm going to list the coefficients of my dividend polynomial, and that is 1, 5, -2, and -10, right? So I've got 1 x cubed, 5x squared, -2x's, and -10 for my constant. Keep in mind, we don't need a placeholder here, all right? But you always want to be thinking about placeholders. So if our terms did not go down or descend consecutively, 3, 2, 1, 0, cubic, quadratic, linear, constant, we might have needed to use a placeholder. Okay, but in this case, there's no placeholder needed because we have a value for each term in descending order. So the synthetic division is fairly easy. You bring down that first number 1. -5 times 1 is -5. You add vertically. 5 minus 5 is 0. -5 times 0 gives me 0. Again, adding vertically, -2 plus 0 is -2. Multiply, -2 times -5 is +10. So when we add here, the last value we get for our remainder is 0. And so what we know, if the remainder is 0, then x equals -5 is a 0. And we were told that when we started the problem. Okay? So that should make perfect sense to us. We are expecting to get 0 here. So x equals -5 is a 0, but what that means then is the factor x plus 5 is going to be a factor with my quotient. So this allows me to factor my polynomial. I'm going to have f of x equals what would have been my divisor, x plus 5, times my quotient. And remember, the quotient comes from these values underneath here. So that would be x squared plus 0x minus 2. And of course, I don't need to write 0x, so I'm just going to write x squared minus 2. and then plus my remainder of 0. Now, again, I don't need to write plus 0. So if you look at what I have here, I have f of x written in factored form. This piece is f of x in factored form. Now, in order to find all of the other zeros, we are going to need to set this polynomial equal to 0 and solve. So 0 equals x plus 5, x squared minus 2. So if I set x plus 5 equal to 0, I get x equals negative 5. Like, we knew that was going to happen. But over here, setting x squared minus 2 equal to 0, that gives me x squared equals positive 2, or x equals plus or minus the square root of 2. So my other zeros are x equals the square root of 2 and negative square root of 2. Those are the two other zeros found by factoring using synthetic division. So I like to extend on this problem here. So what we started with was f of x equals x cubed plus 5x squared minus 2x minus 10. And we wrote this as x plus 5, x squared minus 2. So one thing we're sometimes asked to do is to write things as linear factors. And x squared is a quadratic factor. But we can think of this as a difference of squares, x minus the square root of 2 squared. So really, if we wanted to write this as a product of linear factors, I could write x plus the square root of 2 and x minus the square root of 2.